And thank you, everybody who has chosen to attend. I know there's some good competing talks here, and I really appreciate your interest. So I wanted to talk today about Rejected. And Rejected is a consumer framework that I first started on at my yearbook in 2009. And I've been running in production in multiple organizations since then. And so one of the first things that you may ask is, why would you write a consumer framework? Oftentimes people write applications, they'll go straight to the client library, implement a consumer application. Why put together something like a consumer framework to make it quote unquote more complicated in what you're doing? And so the primary reasons are, I believe in the idea of frameworkizing or creating libraries around things that you find that you do when you repeat yourself. And I always give the advice to my team that it's when you've done something at least 3 times and you're able to extract the common patterns of use or the common problems that you're solving, it's time to start reducing it down either into a library or framework. And so there are things in writing well-behaved consumer applications that oftentimes we don't take into account, when really what we just want to do is get those messages, consume them, do something, maybe talk to a database or a remote API service. Maybe you're integrating with AWS in some way where you're doing something with every message. Having to care about what happens when RabbitMQ disconnects you, or when you have unhandled exceptions, or dealing with things like telemetry and observability within your application itself. Those you start to build up lots of boilerplate if you don't have a framework dealing with those things for you. So you build out these common patterns, and in an engineering organization, it becomes really important from a maintainability, keep the lights on maintenance perspective and a technical debt perspective, that you don't have a bunch of people doing things in all sorts of different ways. It becomes a lot more expensive to maintain a whole slew of different consumer applications if they're all implemented differently and they're all not implementing or caring about the same types of things when it comes to resilience and robustness, for example. And then the other side of that is when all you have to care about is the consumer application itself, it allows for more rapid consumer development. When you don't have to worry about the RabbitMQ connection, you don't have to worry about reconnections or common patterns for configuration. It lets you write applications more quickly. So as I mentioned, Rejected's been used in production since 2009, and version 3 supports Python 2.7 and 3.5 plus. It has support for built-in profiling, instrumentation, and Sentry. So if you have a consumer that has an edge case, it goes to consume a message and runs into a problem, and you don't have exception handling around that, we'll automatically support or submitting that exception to Sentry in an isolated way. So it's not the whole Python stack, it's not things in the framework itself, it's specific to your consumer application as far as the report that makes it down into Sentry, which makes it easier for you to go back and fix things. It automatically handles detecting the message body using the AMQP message type property, and will deserialize messages as they come in automatically for you, so you don't have to deal with that. And if you're publishing as an outcome of consuming a message, that message you publish, if it has a supported message type, it'll automatically serialize that on the way out. And then writing tests around consumers can also be really difficult to get right unless you're going for full integration testing and you're sending different messages through Rabbit. And so one of the things that Rejected does is it provides a testing framework that makes it a lot easier to test in isolation. And it will basically allow you to work in a way where you don't have to have Rabbit running, but you can inject messages into your test cases for the various behaviors that you're looking to get. So one of the other key aspects is process supervision. So over the years, like I mentioned, the rejected dates back to 2009. You could have process supervision for your applications living at the operating system level. So system 5, these days system D, something like that. What do you do when you have unhandled exceptions or behaviors where the consumer is misbehaving? It should be shut down or restarted. And so building a layer that intelligently is able to keep track of all of the consumers that are running underneath it, what their status is, pulling stats and that sort of thing becomes a really important thing. So the model is that there's this single top level controller. It's called the master control program. And it spawns one process per consumer. And consumers can be configured in a way where you're going to say, I'm going to run 10 consumers for this particular class and this set of connections. One common pattern that I use now is, for example, I have a consumer that connects to multiple RabbitMQ brokers, the same queue across or set of queues across those brokers, and consumes from all of them. And that's all configuration based. It also supports publishing only connections. So if you have a circumstance where you might want to consume from one broker and publish to another broker, that's built in, and it will automatically handle all your connection handling for you, the negotiation, handling disconnects, reconnects. And it also allows to, or at least attempts to handle graceful termination for you. That's something that when you're writing a consumer application, and especially a consumer application that is consuming at a high velocity, may not be immediately obvious. How do you make sure that you're consuming and successfully processing that last message before you shut down, instead of shutting down in the middle of processing a message? And that's especially useful where you have consumers that may be doing multiple things. They may be taking that message and writing it out to a database, and then uploading some data to S3 or something along those lines. And you don't want to be caught in a half state. So having that graceful termination is really useful. So now I'm going to talk a bit about rejected consumers themselves. So a consumer is assigned to a single name queue. And really the idea there is that we have both configuration driven consumers where we could say, the same Python class could be named consumer A, B, C, or we could have a rejected instance running that supports multiple different Python packages and classes that are consuming from different queues. They automatically handle unhandled exceptions. So in the case where something unexpected in your code happens and you don't have exception handling around it, like I said, it could submit a report to Sentry, but more importantly, it's going to reject that message with requeue so that another consumer can pick that up and operate on it. It will be restarted. So a consumer process itself is restarted if there's too many unhandled exceptions or a special class of exception within rejected called a consumer exception. So consider the scenario where maybe you're trying to connect to a remote API and they are throwing 503 errors, or you're trying to connect to a database server or something like that. You consider it core to the operation of this application. A consumer exception basically will have an emergency break that will stop the application from running and cause it to be respawned. It has built-in support for both publishing and RPC mechanics. So let's say that you have a HTTP API that is using Rabbit in an RPC mechanism to a consumer application. If you use the reply to queue or the reply to AMQP property, rejected, if you use the reply method, will automatically handle the mechanics of sending it back to the right place. They also support enforcing message types and will automatically drop unsupported messages. So if you use the AMQP message type property, you can, within your consumer class, say, hey, I only accept type A, and this message is either untyped or it's type B. I don't know what to do with it. And so it drops it. And that's a real nice behavior around ensuring that you don't necessarily need to do message validation on input when the broker publishes it to you, or I'm sorry, delivers it to you. Instead, you can rely on the fact that this says it's type A, so I know that I should be able to handle it the way that I expect to. Consumers have basically 4 public methods that they expose for developers to implement. And consumer initialize is the first one. It allows for on consumer creation one-time setup behaviors. And that can be useful, for example, in creating that connection to a database before the consumer starts running and receiving messages. On every message that's received, there are 3 methods that are invoked. The consumer prepare method, and usually what I use consumer prepare for and advocate it's used for is inspecting the message that you've received to determine, for example, if you want to process it or not, and doing any other type of operation that you need to isolate the actual code path for processing the message. And that's where the consumer process method comes into play. It's invoked on every method or every message, and is where the crux of your code should be, at least for the high-level logic around processing that message. Finally, we have the onFinish method, and that's invoked for cleanup, any type of cleanup that you need to do. I've processed the message correctly, but perhaps I want my connections to be set up and shut down on every message for whatever reason. onFinish is a good place for that. So message payloads, if you use the AMQP properties, so if you use the content encoding, for example, and you specify gzip or bzip2, the consumer class will automatically decompress the payload body and make it available to you by the consumer.body property. And if the content type property is set to a MIME type that the consumer class supports, JSON, YAML, XML,plists, message pack. I tried to include things that you got for free within the Python standard library and things that we used fairly common in different environments that I've worked in, or feature requests as they came in. It will automatically deserialize that message payload and expose the consumer.body object or property as the deserialized object or list. So that makes it very easy. You don't have to focus on that deserialization step and making sure that that works correctly. It's very convenient for writing quick, succinct consumer applications. There are 3 built-in consumer exception types that developers have access to or should be using within their consumers. There's that consumer exception that I talked about, that exception that you raise when something really major is going on and you want to make sure that the consumer shuts down if it happens too many times and is restarted, that perhaps it's the kind of thing that a reinitialization should clear up or whatnot. And then there's a message exception. And a message exception is the type of exception that we raise when there is a problem with the message that we've received. And that will reject the message without requeue and drop it on the floor. And finally, there's a processing exception. And the idea with processing exceptions is they are raised when there are transient errors. So I'm talking to that remote API and it's returning a 502 or a 500 error. I would raise a processing exception that would reject the message with requeue, and that would get picked up by another instance of the consumer or the same instance of the consumer. And it's a good way from a application flow and observability and telemetry perspective to know what's happening within your consumer applications. There are class level attributes. So if you specify the consumer message type attribute, the consumer class will automatically inspect the message for you to ensure that the message type is correct. And that can be one of multiple message types if it's in a list as opposed to a string. And it will automatically drop the message prior to it ever reaching the prepare method. So you don't even have to worry about it. And that obviously is documented here in the slide. used in conjunction with the drop invalid messages attribute. If you want to have your drop messages end up somewhere else, somewhat akin to a dead letter exchange, you can specify a drop exchange, and those drop messages will then get republished to that drop exchange. If processing exceptions are raised, they can be published to the error exchange, and that defaults to errors. And we use that mechanism along with queues with a dead letter exchange for retrying and a max message age as a way to get delayed message retries. So then we also have the error max retry. So if you have the same message and it keeps raising processing exceptions and you've gotten, I don't know, 100 of them or 1,000 of them, and you just want to say, hey, after this many times, it's not worth repeating, the error max retry will drop the message instead of doing a reject with requeue. So I've mentioned multiple times telemetry and observability. V3 supports built-in ability to submit counters, gauges, timers to both statsd and InfluxDB. And those are done by methods on the consumer class itself. And if you raise consumer or you raise exceptions within the consumer and including unhandled exceptions, those will automatically be submitted to your configured telemetry backend to ensure that you get some visibility there. So as an example, this is a dashboard in Grafana that we have for a consumer I'm going to talk about as an example here in a few minutes. You could see we're keeping track of information like message processing velocity, the types of messages that we've processed, and processing time is a really key one. So we actually expose the message age in our telemetry so that we could determine the amount of time that a message is sitting in queue before it makes it to the consumer. And that's really useful for determining when queues are backed up, what the impact could be. And it also could be used in calculations for determining an estimated time of processing for a queue backlog. And then with regard to other exceptions, we keep track of the different exception types, and we allow for custom metrics to also be associated with those exceptions via the metric keyword argument in the exception itself, so that you can count specific instances or disambiguate the different types of processing exceptions that you can have. So this is an example consumer. As you can see, it's pretty straightforward. I cheated a little. This is an example for rejected 4, where we've moved from using Tornado's IO loop and gen coroutine behaviors to get our async behaviors to Python 3's async def. So if you were using rejected 3, this would have a gen coroutine decorator instead of async def. But what I'm doing here is I'm demonstrating the different attributes that we have available. So all of the message properties become attributes of the consumer class, as well as the message body. And like I said, let's say this was a JSON payload. That message would then self.body would be the object that was decoded from that JSON payload or the array. I'm just doing a little bit of random number guessing here to demonstrate the behavioral differences between an unhandled exception, consumer exception, processing exception, and message exception. And if we were testing, the base testing system makes it pretty easy to write a consumer test case. We can, for example, in this one, we're checking to see if the message comes in with only an attribute of foo and bar, it's going to raise a message exception. The consumer test case, or I should say the async test case, is going to create a new instance of the consumer, passing in the settings that are returned by get settings. And then when we say self.process message, it's actually going to turn that into a mock, not an actual mock, but an instance of the message that the client library passes through into rejected, so that you don't have to deal with any of that stuff yourself. And process message allows you to set message properties and a few other things. And it would also, from a return value perspective, returns what we call a measurement data class that returns all the telemetry about the message. So if you wanted to make sure that counters were incremented one way or another, or that timers exist for the things that you're trying to do, all of that would be returned in the object that self-process message returns. I do want to deviate a little more. So outside the rejected project currently is another Python package called AVRO Consumer. And what AVRO Consumer allows us to do is in rejected have contract-based message bodies using Apache AVRO datums. And it uses message properties to identify the type. And it can have both a local configuration-based AVRO schemas or a schema repository that it retrieves messages from. And the idea there is that instead of containing all of our data serialization like we would with JSON, for example, or message pack, where we have the field names and the values, it allows us to have a compact data structure where the schema is held separately, and then each datum is basically loaded or deserialized and serialized based upon that schema. And so this is an example of a schema. This is a very early on example for us of what we would use for a message delivery at AWeber. And it basically allows us to have a very strongly typed message body in our RabbitMQ message bus in a way that any number of consumers could consume that message and deserialize it. AVRO is a binary-based data serialization, so you get some efficiency as well on the wire by using that binary-based encoding. And so to illustrate that, I just want to run through real quick an example, a real-world example. And this is a consumer that we have at AWeber for taking in our event bus. So we treat RabbitMQ in a couple different ways, but one of the primary ways we use it is we do event-oriented processing. So whether it's somebody logging into the site or sending an email or a subscriber opening and clicking on an email, we have these events that flow through our system that are consumed by any number of different consumer applications that power our application, whether it's recording customer analytics or submitting content for analysis to ensure it's not spam or anything along those lines. It makes it a really powerful paradigm for what we do. And then the last piece is we actually take those events and we use this consumer to talk to AWS's Kinesis Firehose, which takes that event data, turns it into Parquet files in S3 for us. And that's what powers our data lake and our BI tooling. And it also creates a very powerful tool for us for disaster recovery. If we have a misbehaving application that we need to recover some portion of the event stream for, we're actually able to take those Parquet files, republish them to some specific exchange for that application for it to pick those things up and reprocess them. So I am going to stop sharing my slide deck real quick here. And then I'm going to share if I go down here real quick, we could see, and this is a real production consumer application, and we're using AVRO Consumer and the remote schema consumer for that. And that just means that we're retrieving the schema remotely from a schema repository over HTTP. And we're setting some variables here, including our Firehose client, which allows us to do local testing of the AWS API instead of talking to their AWS API directly. We specify some configuration, including whether or not we have events that we don't want to make their way to AWS. And the meat of our application is we get the Kinesis Firehose stream that we're supposed to publish to. We set a tag in our stats, and that's going to make its way into our telemetry data. And then we check to see if the event's something we're going to throw away. And if it is, all we do is we return and say it's an invalid event. I can't wait to be Python 3 only, and I get to get rid of all this mess. But you can see in this scenario, it's a consumer message exception when we can't decode the message coming in because of a Unicode error. And we are going to increment a metric that shows up in our telemetry that lets us know when we have some invalid Unicode coming through the line. If the stream is set up to include AMQP data, we include additional information about that within what we publish to Kinesis Firehose. And this is a good way for us to be able to figure out where things came from and whatnot. And you can see we use not only the app ID identifying the application that published the message, we also use correlation IDs fairly heavily. And we use the idea of the AMQP property correlation ID throughout our application stack. And it allows us, for example, in logging and in our data warehouse to be able to look things up by that ID so that we can correlate everything having to do with it. Then we're tracking the duration for how long it takes us to call AWS Kinesis Firehose. We're catching whether or not there's an exception. And if there is an exception, which we do receive, we get 500s from them on a fairly regular basis. We raise a consumer processing exception saying, hey, we don't want to throw away the message. We want to process it again. So requeue it. And then we also have the metric that we're keeping track of those exceptions by what stream in Kinesis Firehose we're keeping track of. And that's pretty simple. We're basically got this little method stream for message type. We grab the schema. We build out a string that matches our expectation from that contract. So let's stop that. We'll go back to the slides. And so from a roadmap perspective, and I think I'm running out of time here, Python 3.7 version 4.0 is coming soon. It's Python 3.7 only. Is that not? No, I did not share.
We're not seeing the slides yet. There we go.
Sorry, well, there's only 2 left here. So it's going to be Python 3.7, and that means we're going to use async def, await, Git, and Tornado actually is being pulled out of the guts of rejected, and we're just using Python's built-in async IO loop. We're also introducing a new single process mode. We've moved pretty much entirely into Kubernetes at this point. And one of the things we want to experiment with is having Kubernetes play that role of that orchestrator and using pods dying off in the same way that we would have thought about it, where the rejected MCP is handling that, backing off a consumer and restarting it in those scenarios. And then we're also going to be including AVRO Consumer built into that as well, because we see that as a really powerful way to ensure that we have contract-based data serialization on the wire. So as was mentioned, my book RabbitMQ in depth is out there. I, not being somebody who likes technical books, tried to write it from a way of somebody who likes to dive in deep from a reference perspective and understand the lowest level stuff as opposed to the top level stuff. And I hate contrived examples. So if you enjoy books that take that approach, I highly recommend it. Also, I'm on Twitter, Crab, always looking to have good conversations there. Are there any questions?
Thanks very much, Gavin. Yes, indeed, we do have some questions. So Zachary, are you on? I can see you. Would you mind unmuting and covering your question, please?
Sure, I got a lot. But I think the first one is it's really cool that rejected comes with the kind of testability. And I was wondering if it was possible to test a consumer sending other more downstream messages to other queues, and like a consumer having side effects when they receive a message, and maybe that side effect is triggering another message to another queue. Like, kind of, is it possible to have those kind of end-to-end or integration style tests with the rejected framework?
I mean, the testing framework itself was not built with the idea of doing the integration with Rabbit itself. You very easily could. So using the test class itself, you don't have to actually invoke the self-process message aspect. So if you passed real connection information to it, it would connect to a queue. and you could, in the the setup method, publish the initial message that makes its way into the queue, and for sure could write. It would get a little complex. Haven't had that use case, but if it's something that interests you and you're looking at the framework and say, this would be great, I'd love to use it, except for the fact that, the trigger-based tests for integration or something that's missing. I A, love contributions, and B, an issue on GitHub saying this is how we would like to use it. We have a number of contributors, and I'm sure I have one guy actually on my team that is really deep into testing and is always loving to find new ways to flesh out additional testing functionality.
Yeah, cool. Let's see. Another question I had was for the message exceptions, what kind of data is automatically in those exceptions? Does it have the payload data, and is it scrubbed of sensitive data and stuff?
So if you tell it to republish the message exception, it's going to go off into a different queue, or it's going to get published to a different exchange more specifically. If you, from a what makes it into logs perspective, it allows for custom, there's not a lot that's automatic other than the telemetry that it was raised. It allows for specific error messages to be associated with it. And if you're using the logging mechanism that the way that it's set up and in the examples, that correlation information gets passed along in the logs, but message body and whatnot themselves do not get logged and would obviously not make it into telemetry either. All exceptions have a metric keyword argument that can also be used so that you can specifically keep track of stuff that you want to show up in that telemetry data.
I mean, do you recommend putting the body in there, or what do you think?
I mean, it really depends on your use case. If they're small bodies and there's value in having that make its way into your logs, sure. But I mean, at that point, why not just log everything as it goes in? I would say that if I were trying to figure out the best way to approach that, it might be the kind of thing where on that exception, I'm doing a self-logger info with the message body, and then raising the message error, and then using the correlation ID to see both of those things happen. Logging messages, especially if you're paying for a software as a service platform, where you have like an elk stack or something like that, and depending on what your message velocity, that can get pretty verbose and expensive.
Yeah, definitely know about that. Oh yeah, I had another question. I didn't put it in the Q&A, but on one of your slides, you showed, I think, the graph of the telemetry. And does that come, first party with the rejected framework, or is that you logging it to another service or something like that? Is it rejected?
No, that's actually Grafana. So
okay.
In that case, that is rejected talking to stats D. So you configure a stats D instance, and the stuff goes in there, and then that's going to a graphite server.
Are there shared Grafana configurations or something, so that I wouldn't have to like write those queries and make those graphs myself, or things of that nature?
Not currently, but that sounds like a great thing to document.
Yeah, because so we use what's called Locust, which is another Python library, and there are a bunch of contributors online who've made open source Grafana dashboards and stuff.
I'll have to check into that. One of the things I was looking at adding into, or trying to figure out a good way to add into V4, was improved observability data, and actually also plugging into I'm totally blanking on it. It's the successor to Jaeger and or Jaeger and gosh, I forget. But Locust, I'm going to take a note and I'm going to take a look at it.
Yeah, I was in Ori's talk and he was talking about using Locust as part of Vonage. So that's interesting. The second thing I've heard about Locust today. I also really enjoyed the telemetry part and the observability, and I was interested in using putting message age in there, because that seems like such a simple thing for people to want to track. So that was very interesting. Do you see, or are there any other frameworks that you think we definitely need one of those for Rabbit when you were thinking about making this one?
Well, I think around the early development time, 2009 through 2011, I think Celery was also in early development at that time, and Celery being non-RabbitMQ specific, I felt like there were some gaps in that, which was one of the reasons why we went down that road. I've often thought, is there value in having kind of that same type of abstraction in publishers? And that gets a little more difficult, at least for my own use cases, and trying to figure out how does that work. A lot of my publishing at AWeber and even Meet Me and other organizations that I've done consulting with oftentimes come from HTTP APIs or other ingress points, and not consumer applications themselves. So one of the things we have at AWeber, but it's also very framework specific for that, is we have a common publishing base library, so that we ensure that correlation ID is set and message type is set and our data is serialized and that sort of thing. But those really can become a lot thinner. And especially if using a client library that automatically handles resiliency and reconnections and that sort of thing, I think it becomes less necessary. Consumers, to me, really seem to be the more complicated one, where you have to think through things like, what do I do when I want to shut down and make sure that I don't lose a message, stuff like that.